Bismillahirrahmanirrahim. Now we will study about the testing of hypothesis concerning proportions. Before this we have done the testing of hypothesis for mean and standard deviation or variances for one population and two populations. And this testing of hypothesis related to the population parameter P. You know that the P is the parameter of the binomial distribution. N and P. Binomial distribution you have used in probability. Binomial distribution has two parameters P and N. N is the number of trials, P is the probability of success. So with the help of ratio or percentage of the sample data, we will estimate or test the population parameter P. And if you know that if the outcome of any variable is 2, outcomes are 2, for example, success, failure, pass, fail, yes, no, true, false, survive, die, improve, unimprove, 0, 1, etc., the variable is called binomial variable. So for binomial variable we use the binomial property distribution for probability, same as for testing of hypothesis we will test the binomial parameter in this testing of hypothesis concerning proportions. We will test the hypothesis about the proportion ratio of binomial parameter P. So in this case we consider, this is the definition of this topic, in this case we consider the problem of testing of hypothesis that the proportion part of successes, P is the probability of success, in a binomial experiment equals some specified value. So if the probability of successes is given, or is given means with the help of total outcome we will estimate the probability of success and then we will test the population parameter. You know that in testing of hypothesis for mean, population mean, we use the sample mean. In testing of hypothesis for variance, population variance, we use the standard deviation, sample standard deviation, sample variance. And in confidence interval we estimate the population parameter of, in mean we estimate mu, in standard deviation and variance we estimate the lower and upper value of the sigma and sigma square. Same as here, in this case we consider the problem of testing of hypothesis proportion of success. The proportion of the success, not failure, in a binomial experiment equals some specified value. That is, we test the null hypothesis H naught, that P is equal to P naught. In mean we write mu is equal to mu naught. In standard deviation we write sigma is equal to sigma naught. The same as here, P is equal to P naught. P naught is the value of this P. Okay, parameter is proportion of success P, where P is the parameter of the binomial distribution. Okay, I have already explained this. So these steps for testing of hypothesis about a population proportion, same as the mean and variance standard deviation, we test for population parameter with the help of sample statistic. So using the normal approximation are as follows. You know that in the case of binomial property distribution, when the value of n is large, more than 20, P is more than 0.05, we apply the normal distribution. We use the normal approximation. The same as here, in this testing of hypothesis, sample sizes are large and P is more than 0.05. This is the assumption for this testing of hypothesis. So we will use the normal approximation formula of the normal distribution. So first step, null hypothesis. There are 6 steps, same as the previous, mean and standard deviation. P is equal to mean P naught. Alternate hypothesis will be P naught is equal to P naught, or maybe P less than P naught or more than P naught. Third step, same, alpha is equal to maybe 0.05 or 0.01, etc. Fourth step, test statistic. Z is equal to P estimated value. This P estimated means we will estimate with the help of sample. This is the formula of the P cap, P hat. P cap or P hat represent the estimated value. For estimation, estimated, we use this hat. Read as this hat or cap minus P naught, this value, divided by under root P naught Q naught upon N. And in mean, we write here sample mean. So this is the sample proportion, x upon n. X is the number of success and total number of sample size, where x is the number of successes in a sample of size n. So this is the sample proportion, this is the population. In mean, we write here x bar minus mu naught, divided by sigma upon root n. Sigma is the standard deviation, and you know that the standard deviation of the binomial distribution is under root npq. npq under root. So under root npq divided by n. If you simplify, under root n will be cancelled, in denominator will be under root n. Okay, so P cap minus P naught upon under root P naught Q naught upon n. And what is this Q naught? Q0, read as Q naught. Know that is the property of the binomial distribution, sum of the probability of success and failure equal to 1, P plus Q is equal to 1. So from this you can find the value of Q naught will be equal to 1 minus P naught, and Z is the standard normal variable. Okay. Next step, critical region, same as the testing of hypothesis for mean, one population mean, but in this we will consider the alternate hypothesis P naught equal to P naught. In mean we consider mu is equal to mu naught, and the table value will be represented by same as previous, mean alpha upon 2 for two-tailed test. So this Z is a calculated value, this is the table value we will obtain from table for left hand side. If the alternate is not equal to, left hand side will be negative, right hand side positive. The diagram is same as second option and third option, but we consider this alternate hypothesis. And last step, conclusion, same as the previous. If the calculated value lies in the critical region, we reject the null hypothesis H naught, otherwise accept the null hypothesis. Now confidence interval of same condition, same testing of hypothesis, confidence interval for proportion P. So instead of mu we will write here P, instead of x bar we will write P hat or P cap, minus that alpha upon 2 under root P cap Q cap upon n, same as right hand side with plus sign. So if P cap is the proportion of successes in the random sample of size n, and Q cap is 1 minus P cap, and approximate 1 minus alpha 100% confidence interval for the binomial parameter P is given by. We will estimate the lower and upper value. The objective is same as the mean and standard deviation. We find the lower and upper acceptable value. Okay, now we will solve the question. 200 persons, this is the n, were attacked by COVID-19 and only 18 were died. Test the hypothesis that the survival rate if attacked by this disease is at least 95%. Use 5% level of significance Also construct the 95% confidence interval for binomial parameter P, or simply you can say for P. So how you can say about this question, either this is related to the proportion or mean or standard deviation, etc. So this word 95%, at least 95%, the survival rate is 95% in percentage. If the value is given in mean and test the hypothesis for mean, we apply the testing of hypothesis for mean, population mean. If the value of sigma or sigma square, standard deviation and variance is given or known, we apply the method of the testing of hypothesis for population variance or standard deviation. So in this, the percentage, probability or proportion is given 95%. So test the hypothesis that the survival rate, if attacked by this disease, is at least 95%. Mean standard deviation is not given, as the value of the proportion or percentage is given. Percentage and proportion and probability is same thing. Proportion means the part of the total, percentage means maximum percentage will be 100, minimum 0, so this is the 95%. Or you can say this is the probability, in term of probability will be equal to 0.95. Okay, so this indicate the value of the proportion or percentage is given, and the outcome of the variable are to survive or die, survival rate and died. 200% were attacked by COVID-19 and only 18 were died. The person may be died or survive, improve or unimprove. This indicates this is the binomial variable. Outcomes are 2, yes or no, true, false, success, failure, pass, fail. Okay. So if suppose this statement is not given, in the question you find the probability of 50 survive in same question. So we will apply the formula of the probability distribution, binomial probability distribution. If instead of this percentage mean is given or standard deviation is given, then we will use the testing of hypothesis for mean or standard deviation, etc. So each word is most important, data is most important. Then you can decide either the statement represent the testing of hypothesis for mean, or testing of hypothesis for variance, or testing of hypothesis for proportion, or question related to the property distributions, etc. So 200% N is the 200 were attacked by COVID-19 and only 18 were died. And died means this is the failure. X represents the success. Out of 218 died means 182 survive. So P, proportion, population proportion or parameter value, binomial parameter P, this represents the success. The success rate is 182 out of 200.91. Test the hypothesis that the survival rate if attacked by the disease at least means greater than equal to. Null hypothesis, test the hypothesis represent the null hypothesis. I have explained many times. Is at least means greater than equal to, you have used in probability. 95% means 0.95. Alternate is not given. This is the parallel setup of the null hypothesis will be equal to less than. Alpha is given 5% level of significance. So P cap substitute here in formula of the testing of hypothesis for proportion. P cap minus P naught. P cap is the 0.91. This is the P naught 0.95 divided by P naught 0.95. Subtract 0.95 from 1, you will obtain Q naught 0.05 divided by N. Simplify, you will obtain minus 2.60. Now critical region, less than, alternate is less than, we will select this or choose this. minus Z alpha, find alpha is equal to 0.05, table value from the normal distribution table, same as mean you have used many times, value is minus 1.645. So this value minus 1.645, this is a minus 2.60 lies in the rejected region. Minus 1.645, this is the table value, more than this, but this is the negative value. So this minus 260 is less than minus 1.645. Greater than negative value is the less value. So conclusion is reject H0 and conclude that the survival rate is less than 95%. Reject the H0. Reject this H0. We always test the null hypothesis. Reject H0 means the survival rate is at least 95%. We are rejecting means less than 0.95%. So you can say the survival rate is less than 95%. Okay. Now we will construct the confidence interval for same question. 95% confidence interval for binomial parameter P. Substitute the value P cap 0.91, this is the table value, minus 1.96, P naught Q naught upon 200. Okay. Apply the formula of the confidence interval. So, and then simplify this term. We will obtain this value, multiply by this 0.04, subtract from this minus 87, same as right hand side, add in this value 0.87 and 0.96. So conclusion is we are 95% confident that the proportion of survival rate, this is the proportion of the survival rate, success rate, lies between 0.87 and 0.96. Okay. So this is the testing of hypothesis for proportion, or you can say the testing of hypothesis for binomial parameter P, or testing of hypothesis of binomial variable. And homework, page number 328, solve example number 11, and page number 331, question number 1 and 2 of the testing of hypothesis, and page number 273, question number 2a, and question number 4 for confidence interval. Okay, Allah Hafiz.